Okay, today we're going to learn how to use intercepts to graph equations and functions, and also how to use intercepts with real-world type problems. So let's get started. Okay, so here's your first example. Go ahead and take a moment to read and write this down in your notes, and then we'll move on and get started. Okay, so the first question asks what point represents a miner's elevation at the beginning of the ascent, and then it asks to plot this point. Well, if you read the question, it said that the miners started their ascent at 90 feet underground. Okay, and because that's where they started, that means time would be 0. Okay, they had just started, no time has gone by, so time is going to be 0. And time in this coordinate plane is represented by the x-axis. Okay. Time is going to be 0, and their elevation is going to be 90 feet underground, so it would be negative 90, which is this point right here. Then it asked to plot the point. I just did that, and also to write the ordered pair. So for that first question, part A, the ordered pair would be 0, negative 90. Part B, you're asked to figure out the point that represents the miner's elevation at the end of the ascent. Well, at the end of the ascent, they would be at ground level, right? They would no longer be below surface. They would be at surface level. So if you read this problem, it says after 3 minutes, they reach the surface. So if they are at the surface, they are no longer below. Surface level would be represented by 0, okay? And that's after 3 minutes. So surface, or elevation below the surface, is represented by the y-axis. So if we are at surface, that means we're going to be at 0 on the y-axis. And we get to that point after 3 minutes. So that would be this position right here. And that would be, as an ordered pair, 3, 0. And I want you to notice two things about these 2 points before we move on. So this point is right on the x-axis. And when we have a point that's right on the x-axis, we call this our x-intercept. An x-intercept is just a point that's on the x-axis, or if we're talking specifically about equations and functions, it's the point of the graph that crosses the x-axis. And this point right here that's right on the y-axis would be our y-intercept. And a y-intercept, just like an x-intercept, is a point that crosses the y-axis. So if we're talking about equations and functions, the point on the line that crosses or intersects the y-axis. Part C says to connect these points. And the reason why we're going to connect these points, if you remember our discussion about discrete and continuous graphs, we're talking about time here, so time is going to be continuous. This is not going to be a discrete graph. Time is continuous, so we are able to connect these with the line. That's a better line, and that would be part C. Now part D, at which point did the graph cross the y-axis, which would be our y-intercept? Our y-intercept. Which point did the graph cross the y-axis? That would be the beginning of their ascent, which is when they were at 90 feet below surface, which would be 0, negative 90. And I want you to notice something here. With your y-intercept, x is always going to be 0, okay? And that's because we have to cross the y-axis, so we can't move to the right or to the left. We must move 0 spaces on our x-axis, so x is always going to be 0. And we're going to talk more about that in a bit. And then which point represents where the graph crosses the x-axis? That's going to be 3, 0. And I want you to notice that y is going to be 0, because we're not going. If we want to cross the x-axis, we can't move up or down. We have to be right on the x-axis. So y is always going to be 0 on our x-intercept. This is x-intercept. Y is always going to be 0. We're going to talk about that just a bit. We're going to talk more about that in just a bit. And here it is. So here you have x and y-intercept. We spoke about this already. Just take a look at the definition, write it down, and put it in your notes. All right, so to find the x-intercept of an equation. Okay, so if you notice from our previous example, our x-intercept, what was equal to 0? Y was equal to 0. So to find the x-intercept of an equation, set the y value equal to 0. That's it. That's how you'd find the x-intercept of an equation, because remember, for x-intercept, you can't move up or down. You have to cross the x-axis, therefore y has to equal 0. And to find the y-intercept, all you would have to do is set x equal to 0. That's it. Set x equal to 0, because remember, in order for it to be a y-intercept, it has to be right on the y-axis. You can't move left or right. So let's take a look at this example. Find the x and y-intercept of 3x, y equals 3x plus 6. Okay? So to find the x-intercept, now this equation is, and we're going to talk more about this when we get into slope-intercept form and graphing lines using slope-intercept form. This is in slope-intercept form already. So the easiest way to graph this would be to just use the slope and the y-intercept, right? But if we did want to find the x and y-intercept of this particular equation, to find the x-intercept, we would have to set y equal to 0. Okay, so this is going to be 0 equals 3x plus 6. And you just solve that. That'd be negative 6 equals 3x. And then x equals negative 2. So your x-intercept is going to be negative 2, comma 0. That's where this particular line crosses the x-axis. Y-intercept. Okay, now for y-intercept, you have to set x equal to 0. So anywhere you see an x, you're going to set it to 0. So it's going to be y equals 3 times 0, right? 3 times 0, which is 0, plus 6. So your y-intercept is just going to be 0, comma 6. That is where this particular line is going to cross the y-axis. Okay, let's do one where we'll actually have to graph it. And using x and y-intercepts, pretty simple to graph using x and y-intercepts. So you always have to have at least 2 points to graph a line. Usually you'd want a little bit more than that, but you need at least 2 to graph a line. So with your x and y-intercept, you have both points already, and you can just graph a line easily. This equation is in standard form, which is ax plus by equals c. We'll talk more about that in the next coming days. But if we're wanting to graph this using x and y-intercepts, we'll have to find the x and y-intercept first. So let's look for the x-intercept first. To find the x-intercept, you have to set y equal to 0. So y has to equal 0. So this is going to be negative 4x plus 5 times 0 equals 20. 5 times 0 is just going to be 0, so it would be negative 4x equals 20. That would mean that x is going to equal negative 5. So your x-intercept is going to be negative 5, comma 0. For your y-intercept, anywhere you see an x, you're going to plug in 0. X has to equal 0 for your y-intercept. So it's going to be negative 4 times 0 plus 5y equals 20. That's just 5y equals 20. So y is going to end up equaling 4. So your y-intercept, this particular line is going to cross the y-axis at 0, comma 4. So if we graph that, 0, comma 4 is going to be right here, and that's your y-intercept. And then negative 5, 0 is going to be right here, and that's your x-intercept. Okay, now we're just going to assume this is a continuous graph. This isn't a real-world problem. We don't have a situation, so we're just going to assume it's a continuous graph and connect it with a line, and that would be how to graph using intercepts. Okay, just one more. A lake was stocked with 350 trout. Each year the population increases by 14. The population of trout in the lake after X years is represented by that function. So we're going to graph this again using X and Y intercepts. So you have f of x here, but remember f of x and y are interchangeable, so you could just go ahead and change it to y equals 350 minus 14x. Okay, now to find your x-intercept, anywhere you see a y, you're going to plug in a 0. So y has to equal 0. So that's going to be 0 equals 350 minus 14x. So we would subtract 350 next, we get negative 350 equals negative 14x. And if you divide both sides by negative 14, you get x equals 25. So your x-intercept is going to be 25, comma 0. All right. Now for your y-intercept, you'd have to set x equal to 0. So anywhere you see an x, you just put in a 0. So that's going to be y equals 350 minus 14 times 0. 14 times 0 is 0, so it's just going to be y equals 350. So your y-intercept would be 0, 350. And if we graph this on our coordinate plane, your x-intercept would be right on the x-axis, and that's why it's an intercept. and your y-intercept would be right on the y-axis. Okay. Now this again is in as time, so it's going to be continuous, and therefore we can connect it with a line. It will not be discrete. That's how you basically graph with x and y intercepts. We're also going to talk about how to interpret this. So the way you would interpret this is after 25 years, your trout population would be diminished. There wouldn't be any more trout in that particular lake. Okay, that's how you would interpret the intercepts in this particular graph. And that's it. Have a great day. I will see you tomorrow.